Okay, so there is one small things left, so that I want to finalize in this last lesson about addition and subtraction formulas. So let me start with some examples. Determine the exact values of, say for example, sine of 15 degrees cosine of 105 degrees, and say tangent of 15 degrees again. So we want to determine the exact values of these expressions, yes? These sine, cosine, and tangent. So you hopefully know that these angles are not famous angles. The angles that are famous are the ones that we have in the table, in the formula sheet. But now, this is none of them. But then you need to find a way that connect these angles to the angles that you already know some information about them. For example, here in sine 15 degrees, how can I use these addition and subtraction rules to connect sine of 15 degrees into the information that I have in the table? Yes? Yeah, 45 and 30 are famous. Here we have two options. 60 and 45 is also famous. So sine 15 degrees is equal to sine of, say, 45 degrees minus 30 degrees. Of course, I could write 15 degrees in infinitely many different ways, but they are not useful. The only useful one is the one that we have here, yes? 45 degrees minus 30 degrees, or 60 degrees minus 45 degrees. In this case, both of them will work. Okay, so then you need to remind yourself about the formula that you had. So it becomes sine of the first one, cosine of the second one, and then minus sine of the second one, cosine of the first one. Yes? And then you read out this information from the table. So this becomes square root of 2 over 2. Cosine of 30 degrees is a square root of 3 over 2. Sine of 30 degrees is 1/2. And cosine of 45 degrees is exactly the same number as sine. And then you simplify this. So this becomes square root of 6 over 4 minus the square root of 2 over 4. And then because the denominators are the same, so let me just take the common denominator, and this becomes square root of 6, the square root of 2. So that's the exact value of sine of 15 degrees. So because I didn't solve these kinds of problems for you, even though they are simple, but I just want to make sure that you really know how to solve. If you had started from sine of 60 degrees minus 45 degrees and then do the same thing, it will give you the same result. Okay, but these two options are the only options, because of course I can write 20 degrees minus 5 degrees. I can open it up as sine of 20 degrees cosine of 5 degrees and the other way around. But the problem is that I don't know anything about sine of 20 degrees. I don't know anything about cosine of 5 degrees. So even though what I write in that case is also true, but it is useless. Anyway, now hopefully you know what to do with cosine of 105 degrees. What is your suggestion? So this was the first one. The second one. Yes? Cosine of 105. 45, yes. But I have to add them, yes? So it becomes cosine of 105 degrees is equal to cosine 60 degrees plus 45 degrees. But the formula for cosine, you have it in the formula sheet, so I have it in my memory. So it becomes cosine of the first one, cosine of the second one, but minus. In the case of cosine, if I have plus, I will have minus sign there. it becomes minus sine 60 degrees sine of 45 degrees, yes? And then if I continue, this becomes 1/2. This becomes square root of 2 over 2, minus this becomes square root of 3 over 2, and this becomes the square root of 2 over 2. So if I calculate them, it becomes square root of 2 over 4, and then this becomes what? Minus the square root of 6 over 4. So it becomes opposite of that, yes? First of all, did you expect to get it? Because this number is definitely negative. The square root of 2 is less than the square root of 6. So definitely this number is negative. Could you expect that this becomes a negative number? Why? Because 105 is in the second quadrant. In the second quadrant, cosine is negative. So what we get here is exactly according to our intuition. But you see, the difference is just a minus sign. Could you anticipate that without addition and subtraction formulas? Could you see why cosine of 15 degrees in principle, as we calculated here, it becomes clear now that these two numbers are opposite. If you multiply this one by a minus sign, this becomes square root of 2, this becomes minus square root of 6. So this number and this number are opposite to each other. And I used addition formula to confirm that. But could you, before doing this calculation, so that these numbers are opposite to each other? I mean, the famous rules that we have so far. Yes? Yes? Yeah, complementary, not yet, or might be, I don't know, supplementary and complementary, I think both need, aren't they? Because the complement to this is minus 15 degrees. Yeah, so yes, you can use just complementary, yes? So I hope that you agree with me that cosine of 105 degrees, if I ask you what is the complement to 105 degrees, it is what? It's minus 15 degrees, yes? So this becomes sine of minus 15 degrees. This is the famous rule that we had, yes? Why this is the case? Because if I add these two angles together, it becomes 90 degrees. So 105 degrees and minus 15 degrees are complementary. So the cosine of one of them is equal to the sine of the other one, okay? And then do you remember that we also had the trigonometry of opposite angles? In the case of sine, if I have a negative sign here, I can pull it out, yes? So it becomes minus sine 15. So yes, so you could, if these are given in one single problem in the exam, you can really solve the first one and use this idea to say that, okay, the second one is the negative of that, okay? So this is something that really didn't need these new lessons. We could immediately confirm that cosine of 105 degrees and sine of 15 degrees are opposite. Okay, and what about tangent of 15 degrees? Because in the Swedish system you don't have formulas for tangents, so it means that you have to solve it using sine and cosine. Sine is already done, it's here, and then what we have to do is just do the cosine. Cosine of 15 degrees. So let us just do that, okay? So cosine of 15, so let me write this. Tangent of 15 degrees, which is my question mark, is equal to sine of 15 degrees divided by cosine of 15 degrees. Because as I told you that there are no independent formulas in your course for tangents. Okay, sine of 15 degrees is already calculated, so the only thing that I need to calculate is to calculate cosine of 15 degrees. So cosine of 15 degrees, let us, this time, for 15 degrees I use this pair, 45 and 30. Let us use the other pair, this one, this time. So it is cosine of 60 degrees minus 45 degrees. I could, of course, stick to the same pair, but just for not repeating things, let us just do this. So then the formula is cosine of the first one, cosine of the second one. Yes? And then plus sine of the first one, sine of the second. Okay, and then if you calculate this, it becomes what? 1 over 2, and then cosine 45 degrees is the square root of 2 over 2, and then plus sine of 60 degrees is the square root of 3 over 2, and the square root of 2 over 2. So what happens? This becomes square root of 2 over 4 plus square root of 6 over 4. And then this time you add them, it becomes square root of 6 plus the square root of 2 over 4. So that is the cosine of 15 degrees. So they are very similar, but okay. So, but tangent 15 degrees now, so the question mark, which is tangent of 15 degrees, is equal to what? Is equal to sine of 15 degrees, which is this number, divided by that number. And then, of course, these two 4's are simplified. What do I get is this. Okay. I can simplify it a little bit. For example, if I factor a square root of 2 out, what is left? I can also do the same thing here. So square root of 6 becomes the square root of 3. The next one becomes minus 1. The same thing here, yes? And these two are cancelled. So what do I get is the square root of 3 minus 1, square root of 3 plus 1. So this is the tangent of 15 degrees, okay? But let us check that we have done it correctly. Let us see how GeoGebra answered these questions. GeoGebra, let me put, for example, sine of 15 degrees. But in CAS view, I think the default mode is radians. So if I put 15, what do I get, do you think? Yeah, it doesn't calculate. Okay, so but let me write sine of 15 because I want to make it degree. So I go to this f of x and choose degree. And that's the exact value. And that's exactly the answer that I got there. Yes, a square root of 6 minus a square root of 2 multiplied by 1 over 4, which becomes exactly divided by 4. So that's correct. Yes. But now let me... what is this doing to us? Crazy. I don't understand anyway. Okay, so let us just do tangent 15 because my suspicion is that this will give you a little bit different number. Okay, so tangent of 15 degrees. And let me choose that one and then press enter. So this is the answer provided by GeoGebra, which is not exactly the answer that I got there because I had got a fraction. But I just wanted to teach you this one because that's also important. So let us go back to the board. Can you see why these two numbers are equal? The number provided by GeoGebra, as you see, is 2 minus the square root of 3. The answer that I got is the square root of 3 minus 1 divided by square root of 3 plus 1. But these two numbers are equal. Let us see why. And this method, of course, in the exam, if you stop here, that's okay. Unless that's a multiple choice question, then if you get this one, then you will get confused which one is correct. Okay, so this one, I will write it in green, so that is not really part of the solution if you don't like it. But this method, there is a method called rationalizing a fraction. What do we mean by that? If you have a fraction that you have a surd sign in the denominator, this symbol is called the surd sign or the radical, okay? So if you have the surd sign there, you can rationalize the denominator. Rationalizing the denominator means write a fraction equal to your previous fraction, but in a way that you don't have any surd signs in the denominator, even if the price for that is to make the numerator even more complicated. So what we care is not what happens to the numerator. What we care is to get rid of surd sign in the denominator. And of course, to raise this to power 2, this is the idea. You multiply everything. So you rescale the whole fraction by the conjugate of the denominator. So you multiply the numerator and the denominator by this expression. So first of all, you see that I have done nothing, because if I ask you what this value is, the value is 1. And if you multiply 1 by this number, this becomes exactly the same number. So this is legitimate, yes? Okay, so but why this is good? Because when I multiply these two, it becomes the conjugate rule. So it becomes square root of 3 to the power of 2 minus 1 to the power of 2. And then I become happy because my goal was to get rid of this third sign. Using this trick, it will help me to get rid of it. But then, of course, this one multiplied by that. Here, coincidentally, they are the same. So I have to write it as this one to power 2. Yes? So then I have a square root of 3 minus 1, a square root of 3 to power 2, which is 3 minus 1. And then I use the squaring rule to raise it to power 2. So the first one squared, 2 times the first one times the second one, and the second one is squared, yes? And now what happens, this 3 and that 1 becomes 4, and then I have minus 2 square root of 3, and the denominator is also 2. Now finally, I factor a 2 out, and then I have 2 here, and this 2 and that 2 are cancelled, and that is the exact answer provided by GeoGebra. So the answer that we got here by this calculation is confirmed that it is equal to the one that GeoGebra provides. Any questions here? Okay, so let us practice this a little bit by doing this exercise. For example, I use this trick to calculate cosine of 15 degrees, but because I had already calculated sine 15 degrees, I could also use double angle formulas. This is not part of the lesson, this solution, but I'm trying to draw your attention to different ways of calculating the same thing. So for example, if I ask you what is sine of 30 degrees, let me change my color. So if I ask you what is sine of 30 degrees, of course you already know the answer. On the one hand, if you look at the table, sine of 30 degrees is what? 1/2. This we already know from the table. On the other hand, we have a double angle formula, cosine. I'm just drawing your attention to different ways of thinking about the same problem, okay? So sine of 2 theta is 2 sine theta cosine theta. Okay, so what I do, let us choose theta to be 15 degrees and put it in this formula. So what happens? Instead of theta, I put 15 degrees, so the left-hand side becomes sine of 30 degrees is equal to 2 sine 15 degrees times cosine 15 degrees. Yes? Is that understandable? So if you see this, you shouldn't get surprised, yes? Any sine can be written as 2 sine of the half of the angle, cosine of half of the angle. Okay, why this is good? Because sine of 30 I know, sine of 15 I already calculated in the first step. So I can use this rule also to calculate cosine of 15, but that was good enough. I'm just drawing your attention to another way. So this one is what? Is 1/2 is equal to 2 times sine of 15 degrees in the first line. The answer is there. It's the square root of 6 minus the square root of 2 divided by 4. Cosine of 15 degrees is not known. Let us see if we can get the same answer there. Again. Okay, simplification. Do you agree with me? These 2 and this 4 are simplified. 2 is left. And then this 2 and that 2 are simplified. 1 is left. So these 2 and 4 and 2 are completely gone. So it is 1 equals to square root of 6 minus the square root of 2 cosine 15 degrees. And if I ask you what is cosine 15 degrees, you have to isolate cosine 15 degrees by dividing by this. So if you divide the left-hand side by that, what you get is cosine 15 is equal to 1 over square root of 6 minus the square root of 2. So this is the answer that I get here from this method. That was the answer that I got there from that method. But again, we have to confirm if you don't want to be in trouble. So cosine of 15 degrees, I haven't done any mistakes and I got this answer. And I hope that you understand that I haven't done any mistakes. I got this answer. But these two answers should be the same, otherwise I'm in trouble. Let us double check using the green method that I told you here, green lines. So how can I confirm that these two numbers are equal? Yes, I have to rationalize the denominator. Why? Because in this answer, you see that the fraction, the denominator is actually rationalized. There are no surd signs in the denominator, but we have two surd signs in the denominator here. So what does it mean? I have to use the same trick. Rescale it by the conjugate. Yes? And then what happens in the numerator? It becomes the square root of 6 plus the square root of 2. But this and that forms a conjugate pattern. So it becomes first one squared minus the second one squared. But what happens now? This becomes square root of 6 plus the square root of 2. 6 minus 2 is 4. That's exactly the same number. So that was also a different way reminding you about how you could use in principle the double angle formula rather than subtraction formula for cosine to calculate the same thing. But the problem is that I prefer this method because this method is independent from what we calculated here. But this method depends on what we calculated in the first line. So if it is in the exam, if you want to solve it in that way, you have to yourself find sine and then find cosine. But in this method, you just directly find cosine. So that is more, that is superior to the other method. But it is good to see one single problem from different perspectives. Okay, any questions so far? Yeah? Okay, let me give you another simple example. So another simple example is determine the exact value of each one of these expressions. So let me just simply write it, determine the exact value. Okay, so number one. I make it simple because I just want to send you the message of this exercise. So for example, what do you think will be the exact value of this? Cosine to the power of 2, 22,5 degrees, minus sine to the power of 2, 22,5 degrees. You want to find the exact value of this. Of course, you might not have the formulas in your head, but what I expect you is that to see that this combination is famous in trigonometry. Yes? Do you have any idea? Yes?
Well, 22.5 is half of 45.
Okay, then what?
Well, you could write instead of.
Okay, I can, but that doesn't help. No, the combination cosine squared plus sine squared was famous, which was very elementary, and that answer was 1. And I told you, remember that this combination of cosine squared minus sine squared is also famous.
Cosine 2.
Yeah, that's cosine of the double angle. Yes, so we had this formula before. So cosine squared theta minus sine squared theta is cosine 2 theta. Yes? Oh, thank you. Let us see if this Cambridge have something interesting to solve today. Anyway, so how can I solve this one? It is completely fresh. So the answer is what? Cosine. I give the role of theta to 22,5 degrees. So this becomes cosine of 2 times 22,5 degrees. So if you don't remember this combination is famous, this problem is even though extremely simple, you might miss it. So this becomes cosine of which angle? 2 times 22.5 is just 45 degrees, and 45 degrees is a famous angle. And if you look it up in the table, then you get this number. That's it. Another idea, so let us just think about this problem. So what do you think about this? I have sine of 12 degrees and then I have cosine of 48 degrees plus the other way around, sine of 48 degrees, cosine of 12 degrees. Okay? So you want to calculate the exact value of this. Of course, calculator is not allowed. So, any ideas? Yeah?
This should be cosine of
You might have forgotten, but at least you remember the combination, yes? This combination sine, cosine, plus the other way around, sine of the first one, cosine of the other one, plus the other way around,
But is this plus or is this minus?
no, this plus. For sine, it's plus.
But then doesn't it become 40 minus?
No, for sine, it is the same sign. So that is not important because you don't have the formulas in your memory. But I want you to find the idea, understand the idea. Yes, the idea is what? Use the formula, but this is the right-hand side of one of those addition formulas. I hope that you understand that you have to do it in reverse order. So this, I take my pen. So if you look at the formulas in the book, you will see that this is the right-hand side of addition formula for sine. Okay? So then this becomes sine. The angles involved are 12 degrees and 48 degrees. Yes? And then sine of 12 degrees plus 48 degrees is what? Sine of 60 degrees. And sine of 60 degrees is also famous, square root of 3 over 2. So that's also another idea. Yes?
Can you just ask, do these cosine squared theta and sine squared theta?
Yes?
Was that one of those that would be on the formula sheet, so we have to remember that one?
No, that will be.
That will be.
Yeah, these these double angle formulas are in the formula sheet. But the way I wrote it in a way that you can compare the patterns. Yes. If you remember, I used 3 color pens. Yes, when I was doing that. Anyway. Okay, so let us solve one more problem, and then probably that's done. We can see that what we can do else to enjoy life. Yes. And this question, actually, I want to wait for you to solve it because let us see. Example. I want to wait for you for this one a little bit. So let alpha and beta be angles in the, let us say, third and fourth quadrants respectively. Such that say cosine alpha is minus a third. Is it consistent? Yes. And tangent of beta is minus 2. So let alpha and beta be angles in the third and the fourth quadrants respectively, such that cosine alpha minus a third and tangent beta minus 2. Determine the exact value of, say for example, sine alpha minus beta. Okay, I want to wait for you a little bit. Again, this exact is important because might be, even if this problem is given in that part that calculator is allowed to use, some of you might put this number in the calculator by cosine inverse find alpha, by tan inverse you find beta, and then when you have alpha and beta you subtract them and take sine. Even though technically this way of calculating is correct, but that is not acceptable here because even if you have calculator available, you will not be able to find exact values. So I emphasize here that I want to have an exact value. So I want to wait for you a little bit. So what is the starting point?
like what that we have cosine of a number and we know the result of that. So we have a formula for.
Yeah, I start from the formula, yes. Because what is wanted is what? Sine alpha minus beta. But the information, so what I want to answer is something related to the difference of two angles alpha and beta. But the information given to me is either about alpha, cosine alpha is minus a third, or only in terms of beta, tan beta is minus 2. So it means that I have to somehow relate this question mark to the information that I have, okay? So this motivates you might be to use the addition or subtraction formula, in this case subtraction formula for sine. So you read it from the formula sheet, sine alpha, sine of the first one, cosine of the second one, minus sine of the second one, cosine of the first one. Yes? So if I want to answer this question mark, I need to know sine alpha and cosine alpha. I also need to know cosine beta and sine beta. From these four numbers, one of them is directly given to me, yes? And that one is which one? Cosine alpha. So I have this. But that is my responsibility to calculate these three unknowns. And if I know these three numbers and that number given, I put them and combine them and I will find my question mark, yes? So how should I do that? This is a famous problem that I expect you to know. When I was teaching, I gave you two examples. I gave you an example that I gave you sine and I asked you to find cosine and tangent. And I gave you another example that I gave you tangent and I asked you to find the exact value of sine and cosine. And I started them, if I'm not mistaken, not because they are hard, because they are important to remember. Okay, so that's the same problem. So I start answering question sine alpha first. This is extremely simple, yes? Because cosine alpha is given to me. So what can I write about sine alpha? So I know that sine alpha squared is what? Is what? 1 minus cosine alpha squared. This is useful here, yes? Because cosine alpha is given. And that's exactly the famous formula. Sine squared plus cosine squared is equal to 1. I move cosine alpha squared to the other side. But why this is useful? Because this is 1 minus cosine alpha is given minus a third to the power of 2. And then when I raise it to power 2, it becomes minus. This one becomes positive because of even power 1 over 9. And if I subtract them, 9 over 9 minus 1 over 9 is 8 over 9. But this is sine alpha squared. I want sine alpha, so I take square root, but I have to remember to put plus and minus. Square root of 8 is just the square root of 8. The square root of 9 is just 3. If you prefer, instead of square root of 8, you can write 4 times 2. Square root of 4 is 2. I prefer to write as 2 square root of 2, but that's also completely okay. Oh, sorry, I forgot to put plus and minus. Plus and minus 2 square root of 2 over 3. But now alpha is in the third quadrant. Yes, is it third?
Yes.
Yes, quadrant. So which one is positive, which one is acceptable? So therefore, which one is acceptable for sine? In the third quadrant, negative is acceptable. Okay. So I have this number, I have this number. Two of them are left, sine beta and cosine beta. And that is another, I told you, a prototype example. It's good to remember. So tangent is given. I'm supposed to find sine and cosine using that. I don't know if you remember how to start. So I would say that you are telling me tangent beta is minus 2. This means tangent means what? Sine beta over cosine beta is minus 2. To get rid of fractions, I multiply by cosine beta, so sine beta becomes minus 2 cosine beta. Yes? But of course, sine beta is one unknown, cosine beta is the other unknown, so I have two unknowns, but this is just one single equation. I need another equation, and then you know what that is, yes? Sine beta squared plus cosine beta squared is 1. So I set up a system of equations. The first equation is sine beta equals to minus 2 cosine beta, And the other equation is the famous formula, sine beta squared plus cosine beta squared is equal to 1. So I have two unknowns, one of them sine, the other one cosine, and I have two equations. So in principle, I should be able to solve and find those unknowns. Okay. So now, how do you solve this equation? That's simple. For example, in the second equation, instead of sine beta, I take it out and replace it with minus 2 cosine beta because they are equal. A squared plus cosine beta squared is equal to 1. This becomes 4 cosine beta squared plus cosine beta squared is equal to 1. Becomes 5 cosine beta squared is equal to 1. So cosine beta squared is 1/5. So cosine beta is plus or minus 1 over the square root of 5. Yes? Which one is acceptable? Beta is in the fourth quadrant. In the fourth quadrant, cosine is positive. Beta is in the fourth quadrant. So this means that cosine beta is the positive one. Yes? And then what is sine beta? Sine beta is cosine beta multiplied by minus 2. So I take cosine beta and multiply it by minus 2. So therefore, sine beta is minus 2 square root of 5. Here you don't need to decide. This is automatically negative, but it is consistent, yes? Because in the fourth quadrant, you really expect sine to be negative, and it is. Yes? Now, every one of these numbers I now know, yes? So what should I do? I substitute these values there. So instead of sine alpha, I put this number. Multiplied by cosine beta is this number. Yes, am I right? No, I made a mistake. That is sine alpha. Sine alpha was this number. Minus 2 square root of 2 over 3. That's sine alpha. Then cosine beta, which is this number. Yes? And then minus sine. Sine beta is this number, so another minus sign in the sine itself. Multiplied by cosine alpha. Cosine alpha was given to me from the beginning. And that's it. So let us simplify it. If it's not possible to simplify that much, so it becomes minus 2 square root of 2 divided by 3 square root of 5. Minus, 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 again minus 2, 3 square root of 5. Yes. This is it. But let us write it a little bit organized way. I factor a minus sign out. I can also factor a 2 out. And the square root of 2 plus 1 is left, and the denominator is just simply this. Okay, this is not part of the lesson, but if I ask you to rationalize this one, okay, this is also a good opportunity to teach you this. How can I rationalize this one? Rationalize it. This is the end of the story. You can stop here. But you see that there is a third sign in the denominator. If I insist you, for example, to rationalize this fraction, the previous trick will not work here, because the previous trick worked for, I don't know, square root of something plus or minus another thing. But there is only one expression there, and that is 3 square root of 5. So if I want to get rid of a square root sign in the denominator, what should I do? I have to rescale it by the square root of 5, yes. So what I do, I just rescale it by square root of 5 over square root of 5. First of all, I multiplied it by 1, so I did nothing. On the other hand, if I multiply them, it becomes minus 2. Square root of 5 will be multiplied in, becomes square root of 10. So you see that I told you that even if the price is that to make the numerator more complicated, rationalization doesn't care about that one. What happens with the denominator? 3 times 5, which is 15. Okay, so you see that there are no surd signs in the denominator, but that green part is not mandatory. Okay, we have a little bit of time. Let us solve this Cambridge one. There's one question that we can solve, and that is an equation. And this has the this has the highest point there, highest number of points that you can see in this exam. And you are supposed to solve this equation. The question is this: solve the equation. Of course, I will tell you what this means. 3 secant to the power of 2, 2 theta plus pi over 6 is equal to 4. 4 minus pi over 2 less than theta less than pi over 2, giving your answers in terms of pi. Okay, so let us solve this and we end the lesson. So we want to solve this equation. The only thing that you haven't studied is secant, but secant I don't know, have you seen the Google Classroom? That PDF one for the American teacher that I've loaded includes secant and cotangent and cosecant as well. So I don't know how many of you have seen that, but that's not a big problem. So secant of any angle means 1 over cosine of that angle. So 1 over cosine is called secant. That's not a big problem. So how should we solve that? First of all, secant is not something good to work with because we don't know, so let us get rid of it. Okay? So, but of course, when I say secant squared, it becomes 1 over cosine squared. Yes? So this becomes 3. Then I have cosine squared of 2 theta plus pi over 6 is equal to 4. So let me double check if I have written everything right. Yes. So then I want to solve that one. So what's your opinion about it? So let us say that this was given to you in the exam, not with secant. That's exactly at the right level of your lesson. So how should we solve this? Yes, inverse is a good idea. Or you would say that let us get rid of fractions. Let us stick to my rules, okay? I get rid of fractions by multiplying everything by that. So this becomes 4 multiplied by that is equal to what? 3. The first step is to get rid of fractions. What do you think will be the second step? The second, of course, your goal is to isolate your unknown as much as you can. So I have to get rid of this 4. So what I do? I divide by 4. Yes? So what's the next? Because this is second power, I want to get rid of the second power. So I take a square root. But if I take a square root, the left-hand side becomes this. What happens to the right-hand side? Okay, but what happens first?
It becomes square root of 3 over 2.
Square root of 3 over 2 is not complete.
What?
Plus or minus.
Oh, sorry.
So I have 2 problems to solve now. Okay, one with the positive sign and one with the negative sign. Wasn't it extremely simple? So it has a false reputation, I would say, math A level, yes?
This is just a famous.
Okay, well, I'm just kidding, because there are many questions, you have to do it quickly, okay? Anyway, but this is now very simple for you, hopefully. You break the problem into two problems, one with the positive sign, 2 theta plus pi over 6 equals to square root of 3 over 2. Let us see if I can fit it here. Number 2, cosine 2 theta plus pi over 6 equals to minus the square root of 3 over 2. Okay, but do you remember what was the rule for cosines? So this box is equal to what? Plus or minus cosine inverse of the square root of 3 over 2 plus 2n pi. Yes? But that is, as you said, famous. Cosine inverse of the square root of 3 over 2, if you look at the formula sheet, it becomes 30 degrees, which is in radians. Express your answers in terms of pi, so you have to express it in radians. So what happens? 2 theta plus pi over 6 is equal to plus or minus 30 degrees is what? In radians? Pi is always equivalent to 180.
Yeah.
So 30
So
is
2 pi. No, sorry.
pi over 6. Yes? Pi over 6 is 30 degrees. And then plus 2n pi. Okay, then the problem is again is broken to two parts. One with the positive sign. Yes? And one with the negative sign. I will of course add n belongs to z at the very end. So and then it is simple. You see this pi over 6 and that pi over 6 are gone. 2 theta is 2n pi, so I divide by 2, it becomes n pi. This is one group of solutions. N is an integer, so let us just drop that. And now this one, let us do it in our head. Pi over 6, I move it to the other side, it becomes minus pi over 6. Minus pi over 6 minus pi over 6 is minus pi over 3. Minus 30 minus 30 is minus 60, yes? And then you divide by 2. So what happens? Theta minus pi over 6 again, plus n pi. That's another group of solutions. But I also have this to handle. Yes? So 2 theta plus pi over 6 becomes plus or minus cosine inverse of minus the square root of 3 over 2 plus 2n pi again. But this number, you need to look at in the table. So this number is the supplement rule, yes? Square root of 3 over 2 was 30 degrees, so that supplement becomes 150 degrees. But 150 degrees is 5 pi over 6. So it becomes plus or minus 5 pi over 6 plus 2n pi. Again, I have to break the problem into two parts, one with the positive sign, one with the negative sign, yes? Yes? So I hope that you are not confused. You see, I already knew the answer to this is 30 degrees. But now I want to have negative, and that is cosine. I remember the cosine, the trigonometry of supplementary angle. So the supplement to 30, which is 150, will work. Of course, I think this is in your table. You can check it out. Okay, and then the answer is 5 pi over 6. Why? Because 150 degrees means 5 pi over 6 radians. Okay, so because there is no space here, let us do the calculations in our head. Okay, so I move this to the left. It becomes 4 pi over 6. And then I divide by 2, it becomes 2 pi over 6, which is pi over 3. And then plus n pi. Double check. I move this to the left. It becomes 4 pi over 6. I divide by 2, it becomes 2 pi over 6. I simplify by 2, it becomes pi over 2. That's correct. And if I move this to the other side, it becomes minus 5 pi over 6 minus pi over 6, which is minus 6 pi over 6, which is minus pi. And then I divide by 2, it's minus pi over 2 plus n pi. Okay. So I got all 4 possible scenarios, but the problem is not finished yet because we're supposed to find the answers in this interval. And then you have to start doing it. For example, so let us just do it. I'm not a little bit tired. Let us just do it. Okay, so what happens here? Do I have any answers coming out from here that fits here? One answer, and that is for n equals to 0. Because if I give n equal to 0, I will get 0. But if I give 1, it gives me pi, which is beyond this. And if you give minus 1, it gives me minus pi, which is also beyond that. So from all these solutions, only 0 is acceptable. Yes? What about this one? Let us check. Do you think it is good to give a minus 1 here? No. Minus pi over 6 is already beyond that minus pi over 2. So there is no point that I go to more negative values. So let me choose 0. If I choose 0, it gives me minus pi over 6. Minus pi over 6 is acceptable. Okay, the positive values. Do you think positive 1 works? No, because pi minus pi over 6. Pi is 180, pi over 6 is 30. If you subtract them, it becomes 150. 150 is beyond 90 degrees. So no, that's it. One answer from this group, one answer from that group is acceptable. Now let us go here. So, negative value does not work here, but 0 works. So, theta is equal to pi over 3 is another answer. And how you see that if I give 1 doesn't work because pi plus pi over 3 is already beyond pi over 2. What about this one? Because this is strictly smaller than or greater than, 0 does not work. Because if I give you 0, it gives me exactly minus pi over 2, which is not acceptable. But if I put 1, again, not acceptable, because if I give 1 pi minus pi over 2 is positive pi over 2, which is also not acceptable. Yes, do you agree? So, that's it. So I have 3 answers. 0, pi over 3, and minus pi over 6. These are the answers. So, it was not that hard, you see, but you have to do things quickly. Because I don't know, there are how many questions here. There are 12 questions. Most of the questions has more than 1 part. Mainly all of them have 2 parts. And the question time is just 2 hours. Okay, so you have to be able to do it quickly, but it is not that hard. Anyway, is that okay? Okay, have a nice weekend. Thank you.